In this video we're going to talk about trigonometry. The first thing I want to draw your attention to, let us suppose you have a triangle like this. It's a right angle triangle, and then this is 1, and this is y, and this is x, and this is theta. If I want to find the opposite, or maybe the adjacent, I can use so if I use sine to find the opposite of a hypotenuse is equal to sine. Therefore sine of theta is equal to the opposite, which is y, divided by the hypotenuse, which is 1. And then cos of theta is equal to adjacent divided by adjacent of a hypotenuse. So adjacent is x, and x over 1 is x. So from here we can use Pythagoras theorem. And by using Pythagoras theorem, we can draw an identity here. Pythagoras theorem basically is the sum of the square of the two shortest sides is equal to 1 to the square. So we are saying that x, which is cos of theta, therefore cos of theta to the square plus y is sine of theta, so sine of theta to the square is equal to 1 to the square is 1. So this is our first identity. Also I want you to know that 1 over sine is equal to cosec, and that 1 over cos of theta is equal to sec of theta. Alright, and that also cos theta over sine theta is equal to cot of theta. Similarly, if we have the sine of theta over the cos of theta, we should be able to get the, let's say here, sorry about that, so the tan of theta. Now from here, where do we go? Let us see. If we divide by cos square theta, what are we supposed to get? So we're going to get cos square theta over cos square theta plus sine square theta. I'm dividing by cos square throughout to get one more identity. So divide by cos square theta. Cos over cos is 1 plus sine over cos is tan, so that's tan square theta is equal to 1 over cos square theta, and 1 over cos we know is sec, so we're going to get sec square theta. This is our second. It doesn't come in real order, but this is the first basic identity. Alright, and from here emanates another one. Okay, this is how we draw our identities. And also now if we want to divide, let's say by sine, so divide by sine square theta, what's going to happen? Take this, so cos square theta over sine square theta plus sine square theta over sine square theta is equal to 1 over sine square theta. So basically cos over sine is cot, so we've got cot square theta plus 1 is equal to 1 over sine is cosec. So there we got cosec square theta. So here's another identity which is very important that we're going to be using throughout this chapter to solve, equation as well as prove identities. And now if we go further, just push this a little bit up. Right, okay. You might have already known that, but it's very important, to come with this as well. You might have already come across the sine graph, basically. So what does this y is equal to sine of theta looks like, the graph? Okay, we're talking about the graph. So basically 1 over sine, y is equal to sine theta. It's going to look something like this. So this is 0 and this is pi, this is 2 pi. So this is x and this is y. Okay, just bear with me one moment. At the same time, if I want the y is equal to cosec, so let me just put this one in green. So y is equal to cosec theta. So basically the graph will look something like this. just put this like this here. So your sine graph is like that. So what you do, you just draw a line here, and the inverse of it is like this. So the graph will look something like here, and then you're going to get an asymptote here. It doesn't touch this line. So this is from 0 to pi, 0 to pi, or pi is 180 degrees, all right? And then over here you've got this, so the graph goes like this here. So there we go, right? And over here you got 2 pi. Remember that these values, they can be in degrees as well, right? So this is your x-axis and this is your y-axis. So we're going to look at some other graphs as well. Now let's look at the cosine graph. Okay, if I have y is equal to cos of theta, we know that this graph looks something like this. You've learned this from your studies of AdMaths in O level. Alright, so this is very much applicable here. So we're going to look something like this. Not very good at drawing, so I don't know how many times I repeat myself throughout the years about this. Let's call this theta if you want, and this is y. Well, this is not x, this is basically theta, right? If you want to be very much into this thing, precise, you know. So, and remember, these are 1, minus 1, 1 and minus 1. And you've got 0 here, so this is basically you've got minus 1 here and 1 here. It's very important to know these graphs, because when you do your numerical solutions, these might appear as well in this other chapter. So you will see how, anyway. We will go through this at some point in time in the future, and we can have let's say here y is equal to well, sec of theta. Okay, so if y is equal to sec of theta, we're going to look at the inverse of this. The inverse will go from here. Let me just, if you want to put it in green here, you go from the 1 all the way up like this. But I don't want to spoil this graph, okay? So let's forget this. All right, so what I'm going to do, I'm going to draw the graph separately. Let's suppose our cosine graph was looking something like this. Something like this. Okay, so from here, from 1, you're going to get the graph going up here. Okay, and this is at 90 degrees, which is pi per 2. So this is pi, this is 2 pi. Okay, so pi and 2 pi. Okay, now from here, we're going to get here, something goes like that, at minus 1. So then at minus 1, okay, your graph will look something like this. This is basically 90 degrees, pi per 2. Okay, and then you're going to get an asymptote here, and this is 270. So then the graph will go something like this over here, because here if the graph continues and it goes like this, so like this and like this, and then this goes all the way to 2 pi. Okay, and well, right, if you look at 270 degrees, we know that pi radian is equal to 180. So we're saying that pi is equal to 180 over 2 pi. I mean 180 over pi. Okay, so if we look at what I'm saying is pi radian is equal to 180 degrees, and therefore I want to know 200, because here is 270 degrees. If you convert this in pi, so you're going to get pi over 180, okay, times 270. It's going to give you 3 over 2 pi. Okay, so I can't remember this by heart. 3 over 2 pi. Okay, so this is y and this is theta. this is how we draw some of these identities, which is very important for your studies. I'm going to go through some other important things when it comes to trigonometry again. All right, and let us suppose now, if you have a triangle, these are basic things that we should know, all right, especially when it comes to exact values. You can get a triangle like this, and in this triangle, let us suppose that this is 60 degrees. We all know that 60 degrees is half, cos of 60. Cos of 60 degrees is equal to half from your calculator, right? There is no doubt about this. I set my calculator in the degrees mode. Okay, I don't need to go into this like proving something here, but again, you know, cos, there we go, half. All right, so how do we relate this triangle to this value here? So what we do, call this 1, okay, and we put this as, you see, the adjacent over the hypotenuse. So cos is adjacent, which is 1 over the hypotenuse, which is adjacent over hypotenuse. So adjacent is 1 and the hypotenuse is 2 here. Well, let's say this is 2 here. So this is cos. And if you use Pythagoras theorem, by Pythagoras theorem, this opposite side here will be 2 to the square minus 4 to the square. So 2 to the square, which is 4, minus 1 to the square, then this becomes 3. And then you do the square root of 3 to get this thing. The Pythagoras theorem says that, let's suppose this was x, let the opposite is equal to x, you're going to get 1 square plus x square is equal to 2 square, so x square is equal to 4. Send the 1 on the other side, so x equal to 3 and the square root of 3. Here we are. Now, from this triangle, which you should remember, we can derive, let's say, sine of 60. Sine of 60, yes, is the opposite over the hypotenuse. The opposite is root of 3 over the hypotenuse, which is 2. Let us see from our calculator. Sine of 60. There we go. Root of 3 over 2. And here we are, root of 3 over 2. And also, if you want to have the tan of 60, tan of 60 is the opposite over the opposite over the adjacent, which is then root of 3 over 1, and that becomes root of 3. So these are some exact values when it comes to angles, right, in particular situations. Now, the other thing that we are going to look at is, let us suppose now this angle here, of course, has got to be 30 degrees because this is 90, this is 60, and the sum is 180 in a triangle. So we can also look at the exact values of this angle here. All right, so let us see. Now, if you want the cos of 30 for this triangle from this point to this is the opposite. Opposite 30, you got 1. And then this is the adjacent here. So cos of 30 is equal to, let's see, cos of 30. Just do it here. Cos of 30 degrees. Cos is adjacent, this is the adjacent over the hypotenuse. So we got then root of 3 over 2. Let us try and see. So cos of 30, you're going to get, yeah, that's exactly what it is, all right? There's no mistake about this. So then sine of 30 is the opposite over the hypotenuse. This is half. And then you've got the tan of 30. Tan of 30 is going to be equal to opposite over hypotenuse. Opposite over socatua. Opposite over adjacent. 1 over root of 3. Which is basically root of 3 over 3. Yeah, this is the same. Okay, so tan of 30 is root of 3 over 3. It's very important that you know these. For instance, now, when it comes to, we're going to look at a simple example. Let us suppose I ask you to find the exact value of let's say cosec 240 degrees. Okay, the first thing we'll look at is where this 240 degrees is from our quadrants. We have, this is the y-axis, this is the x-axis, and let's suppose that this is well, all silly teachers, science teachers, okay, teach, right, and then this is cos, and here we are. All right, so what is 240 degrees? So if you have, this is 180, so 240 will fall in here. Okay, if you look carefully, this is 0, okay, this is 90, this is 180, that's 270, and then come back to 360, a complete angle. So our angle is here in this quadrant. All right, so we're looking at, say here, anti-clockwise, this is 240 degrees. And from this 240 degrees here, you've got 60 degrees. Why? Because this is 180. 180 plus 60 is 240. Right. What is the cos of 240? Now, cosec. We did say that, okay, let's see. Cosec. Cosec of 240 is exactly as 1 over sine, because cosec is 1 over sine, so 1 over sine 240 degrees. So that means 1 over, if you look at here, all is positive, here only sine is positive, and here only tangent is positive. Therefore, from this quadrant here, sine, because angle is falling in the third quadrant. In the third quadrant, only tangent is positive. The tan value is positive. So sine will be negative, cos will be negative of here. So I can say over negative, all right, sine of this angle here, 60 degrees. This is the same as this. These two are the same. Right. So now, what is sine of 60? Well, we did sine of 60, root 3 over 2. So I'm going to say 1 divided by negative root 3 over 2. Meaning that this is going to become minus 2 over root of 3. And this is cosec of 200. You can't look at cosec in your calculator, they won't give it to you. So, but what you can do, you can say 1 divided by sine of 240. This is negative 2 root of 3 over 3. Negative 2 over root of 3 is the same as negative 2 root of 3 over 3, because we did say that 1 over root of 3 is root 3 over 3. So this could be, or you can say minus 2 root of 3 divided by 3. It's the same thing. Right. So this is something that we should know. All right. I mean, this is not part of the, it's like an example here. Let me just put it as an example for you. Now we are going to look at, let us say we want to solve an equation. All right, I'm not going too fast, but I'm sure you'll be able to follow. You can stop and rewind the videos at any given time if you want. Okay, so suppose I tell you to solve the equation, let's say sec square x, okay, minus tan x minus 3 is equal to 0 for, let's say 0 degrees less equal to x less equal to 360 degrees. So what we're going to do, we're going to convert, first of all we're going to set our calculator into the degrees mode. Now the answer to this question, let's see, it's not that straightforward anyway. So we got sec square x, okay, minus tan of x minus 3 is equal to 0. All right, so now let us see. This thing here is a bit of a problem. All right, we can use the identity if you want. Okay, let's use the identity. Use 1 plus tan of square x is equal to sec square x, same as sec square x. So you see it there. Just one moment, this video sometimes having some problem to put it all into view. All right, there we go. Okay, so if we can use this, all right, so what we can do, the sec square x is equal to 1 plus tan square x. So we're going to put this as, okay, 1 plus tan square x minus the tan x, and then minus 3 is equal to 0. So 1 minus 3 is minus 2. So I've got then tan square x minus tan x minus 2 is equal to 0. Now this becomes a quadratic equation as much as it is a trigonometric equation. Well, let us see what we can do with this quadratic. Can we factorize? Yes, we've got tan x, then tan x. And I've got 2, so I mean minus 2, so then I've got 1. 1 times 2 is 2. I have to have a minus tan here. So what can I do? I can put this as minus and this one as plus if I want, because see, 1 times tan x is tan x. Minus 2 times tan x is minus 2 tan x. Minus 2 tan x plus tan x is minus tan x. There we go. So you got it? So therefore we got tan x is equal to negative 1 and tan of x is equal to 2. Now from here, where do we go? If we have tan x is equal to 2, okay, let's take the positive value. It's a lot easier to work with the positive. We can get inverse tan of 2. Right, so we're looking for tan inverse of 2. And that makes it 63.4. That's our basic angle. So x is equal to 63.4. Remember, we need to take all angles from 0 to 360 degrees. So what are we saying then? We're saying that if we look at the quadrants, you have all science teachers cheat. Tan again is falling in this quadrant here. So the value will be, this is our basic one. The basic is 63.4 degrees, but the other one is here. So you need to add 180 there to get the second angle. So we're going to get 63.4 plus 180. So the final answer for this part here, 63.4 degrees. And then you're going to take this one and add it, which comes to 243.4 degrees, right? Okay, not very difficult. And for this one, the tricky one, so let's take a look at this. We got then tan, okay, inverse of minus 1. So that's going to be equal to x. So let's move and see what's tan inverse. Tan inverse of minus 1. We're getting minus 45 degrees. Now, x is equal to minus 45 degrees. Let me just put something in red here. It's not in the required range. Okay, not in, border this off, the required range, because our range is from 0 to 360. 0, not below 0, and here this one is below 0. But be careful, we're not going to reject this, okay? So what we do, we want something in the range. Therefore, we take, well, you can say x. X is equal to minus 45 degrees plus 180. Okay, if you take minus 45 plus 180, you're going to get 135. 135 is in the range. So let us see. So x is equal to 135, and let's just test this. If you take the tan of this, there we go, minus 1. Can we have a second one? Well, if you get 135, okay, and you go 180 again, okay, so that's going to be 135 plus 180. Oh, 315 is within the range. All right, so we got then 315 degrees. Let us see if you check it out. So tan over 315 degrees minus 1, basically. There is another way of doing this if you get some confusion. What I do, if I say, let's say x is equal to minus 45 degrees, I take the positive value. I don't take the negative value. Then I look for negative. So this is 45. We take positive value. So whenever you get negative, don't put negative, put positive. Then you have this acronym, all silly teachers cheat. Now, where is tan positive? Here. So we're not looking. Don't look for this. So this is out, because here tan is positive, but we're looking for a negative value, right? So negative value will fall here in this quadrant, there and there. So you're going to get a negative here. So how are we going to get this negative? All right, so this is 180 degrees in all, 180 minus this 45 here. So 180 minus 45, and that comes to 135. So this is our first value of x, and we did check 135, 135. And what about this one here, this angle here? Let's put this in. This is 45. So we're looking at something like this. Let's start here and go all the way like this and all the way here. So that's 360 degrees. Take away that 45. So another value of x is 360 degrees minus 45, and that comes to 315 degrees. So this, oh, okay, wait, this and this. So this is how we solve an equation like this using identities. I mean, this is not all. We got loads of questions that come across different ways. We're going to look at them at some point in